Jimmy Ford, get back in.
Okay. I don't know, we're coming over to the west there. They want you to come back in now.
Roger, we've been trying to talk to you for a while here.
No, back in. Come on. You still got 3.5 more days to go, buddy.
(1965) marked the 15th year since scientists first used this triangular tract of scrubland for missile testing. Today, Cape Kennedy is the focal point of the United States commitment in space. The year opened with two pieces of unfinished business. Mariner, a complex spacecraft launched on November 28, 1964, was in the early phases of a 350 million-mile journey to the planet Mars. And GT-2, the unmanned Gemini spacecraft, still sat atop the modified Titan II booster on Complex 19 after a December fizzle. These missions were completed. GT-2 was successfully launched in January. In July, Mariner zeroed in on its target to give scientists the first close-up pictures of Mars. 1965 was the year of promise at Cape Kennedy. Promise for real achievement in manned spaceflight. Promise for a military boost in space with the first flights of the Air Force Titan IIIC. Promise for more muscle for the nation's deepest ballistic missile weapon system. Promise for advancement across a broad front of scientific investigation with unmanned satellites. The programs at the Cape, which only a few years ago were science fiction, are today becoming science fact. This is the Thor Delta rocket at work. It evolved from an early Air Force weapons program and is now an operational space booster used by Air Force and NASA for most satellite launches. The satellites launched in 1965 gave the U.S. valuable scientific information to study magnetic fields, cosmic rays, radiation, and solar flares. In other applications, satellites launched gave us accurate details about the Earth's topography. They provided live television and communications between continents. And pictures from space to aid weather forecasting. This solid fuel, Blue Scout, hurled a small gold-plated satellite deep into space to measure the uncharted regions of the Van Allen radiation belt. It was one of 5 launched in 1965. In another sharpshooting demonstration, an Air Force industry crew launched the third trio of nuclear detection satellites aboard an Atlas Agena.
2, 1, 0. Ignition.
The satellites were injected into separate orbiting positions to serve as electronic sentries in space. The programs at the Cape vary, but one basic mission has not changed: the development and refinement of weapon systems vital to the defense of the United States and the free world. Minuteman II, America's most advanced intercontinental ballistic missile, continued testing during 1965. SAC's operational version will have a striking range of over 7,000 miles. At the Eastern Test Range, the missile is fired to a target area near Ascension Island, approximately 5,000 miles away.
Holding momentarily. ATO switch to proceed. Proceed. Guidance monitor. Number 1, go. LSO go. -4, mark. 3, 2, 1, 0.
Seven Minuteman missiles were fired during 1965. All were successful. A different concept in weapon systems is the U.S. Navy's Polaris, launched from nuclear-powered submarines. Staging from Port Canaveral, each new submarine moves to a position 30 miles off the Cape coast to put both missile and crew through operational tests. The third-generation Polaris has a range of 2,800 miles. During 1965, there were 57 major launches from the Cape. Not so many as in previous years, but more demanding in the areas of launch support, tracking, and data gathering. Cape Kennedy, the downrange stations, and instrumented ships and aircraft make up the 10,000-mile-long Air Force Eastern Test Range. The growing complexity of space missions requires a massive amount of support from the range. Control of satellites, compiling of information for study of rocket performance, monitor and control to ensure safe operations during missile flight. Transition from a ballistic missile testing center to a space operations center will continue as the demands of the nation's most ambitious space program gathers momentum, landing an American on the moon by the end of the decade. The National Aeronautics and Space Administration proceeded on schedule toward that goal in 1965. The Ranger project, completed that year, provided the pictures of the moon's surface that prove there are areas smooth enough for a landing.
All launch commit lights are green.
All recorded as it passed.
I have a commit arm light. Mark. Ignition.
The world saw on television what Ranger saw as it approached and hit the moon. But more information is needed for the manned landing in Project Apollo. Is the moon's surface solid enough to support the Apollo spacecraft? A NASA Surveyor spacecraft will find out. The Surveyor will be boosted into space by an Atlas Centaur. In a research and development test flight in March, a fuel valve malfunctioned and Centaur raised only a few feet. In a later flight, all systems perform perfectly, setting the stage for the Surveyor launching. NASA's most challenging and complicated steps to the moon is the developing and proving of the launch vehicle. Flight testing of the Saturn I series, which began in 1961, ended in 1965 with a 10 for 10 record. Each of the 1965 Saturns carried a huge satellite called Pegasus as a bonus payload. The giant spacecraft with a 96-foot wingspread made up of paper-thin aluminum panels is designed to unfold in space to detect and report the distribution, size, and velocity of tiny meteoroids hurtling through space. The final Saturn I with Pegasus aboard was launched on July 30th. Onboard television cameras show Pegasus spreading its giant wings in space. Keeping pace with the progress of Apollo is the development of the NASA facilities at the Kennedy Space Center on Merritt Island, just west of the Cape. The Saturn V Vehicle Assembly Building, the mobile launcher, and the crawlers for transporting the 365-foot-tall lunar rocket are rapidly nearing completion. Man on the moon is one direction. However, military capability in space is also required. The space booster to fit this need must be powerful enough to place heavy payloads into Earth orbit, be capable of maneuvering in space, have a support system designed for a fast launch rate, and yet be economical. The answer was the Air Force Titan III rocket, a combination of liquid and solid-fueled engines. In this new concept, liquid fuel stages are assembled as a core vehicle in one of 4 bays of the vertical integration building. The core vehicle is moved to the solid motor assembly building, where huge solid propellant boosters are attached. The entire assembly on its transporter, which serves as a launch platform, is then transferred to the pad. Several payloads can be carried aloft by the Titan IIIC and placed into different orbits by the versatile switch-engine trans-stage. Maneuverability in space is made possible by the unique third stage, which has a stop and restart capability in orbit. A streamlined countdown is conducted from the control center in the vertical integration building.
Electrical, go. Second flight safety, go. AC spark plug, go. UTC, go. Engineering, go. CSO, go. SRO, go.
The test wing authorizes you to proceed with the launch of the Titan IIIC.
Roger. 5, 4, 3, 2, 1, 0.
Over 2.5 million pounds of thrust and a trail of flame 600 feet long is generated by the solid fuel boosters as the Titan streaks skyward. In a weightlifting test, the first Titan III placed 21,000 pounds of lead payload into orbit. 2 later launches carried live experimental satellites. 28 miles up, the spent solid motors are ejected, and the liquid fuel core takes over. Future missions for the Titan III will include a variety of scientific and communication satellites and manned orbiting laboratories to determine man's military potential in space. The greatest and most dramatic of the space achievements in 1965, without doubt, were in Project Gemini, the second phase of America's manned spaceflight program. Gemini is a national effort, directed by the National Aeronautics and Space Administration, and supported by the Department of Defense in booster development, launch operations, tracking, recovery, bioastronautics, and providing flight crews. Television and radio networks spent several weeks re-establishing broadcast facilities at the Cape Press site for the first American manned spaceflight since the end of Project Mercury in 1963. Vice President Humphrey, chairman of the National Aeronautics and Space Council, flew in to observe this important first flight. Over 700 news media representatives from the U.S. and many foreign nations covered the event. Air Force Lieutenant Colonel Gus Grissom, one of the original Mercury astronauts, and Navy Commander John Young, a newcomer, were America's first Gemini twins to fly. On March 23rd, the combined Air Force, NASA, industry blockhouse crew launched the Molly Brown spacecraft on its three-orbit flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
During the mission, the astronauts achieved a first by maneuvering their craft into a change of orbital plane, and then on re-entry, flew the Molly Brown to the selected landing area. The welcome home at the Cape and Cocoa Beach, Florida, was representative of the feeling of all America. GT-4, the second manned mission, followed close on the heels of GT-3. The flight date, June 3rd, was a month earlier than originally planned. Astronauts James McDivitt and Ed White were both new to space, but not new to flight. Both were crack Air Force test pilots. GT-3 GT3 was 3 orbits, 4 hours and 50 minutes. GT4 was committed to 62 revolutions, 4 full days. 4 hours and 29 minutes into the mission, Ed White made American history.
What's your status for EVA? Status is go for EVA. Flight Hawaii, Capcom. Go ahead. Roger, I understand our copy. He is outside of the spacecraft at this time. Trying to talk to you for a while here. No, back in. Come on. We still got 3.5 more days to go, buddy.
The 2 space pilots received a boisterous welcome aboard the Navy's USS-1. GT5, the first real Gemini endurance test, 8 days in space, was scheduled in August and again well ahead of the originally planned date. The endurance champion of the Mercury flights, L. Gordon Cooper, was selected as command pilot. Former Navy flyer Pete Conrad was chosen as co-pilot. After a 2-day slip, the launch was rescheduled and Cape support forces again took position. After a perfect launch in good orbit, problems developed in a new power supply system, and the mission seemed to be in trouble. NASA Flight Director Christopher Kraft decided to continue the mission, evaluating the situation on a day-to-day basis. Department of Defense support and recovery forces throughout the world maintained an around-the-clock vigil should a sudden mission halt be called.
This is NBC News. The flight of Gemini 5.
This is CKSN's coverage of Gemini at T plus 106 hours and 55 minutes.
Cooper and Conrad continuing to streak around the globe at 5 miles a second, now well past the midpoint of their 8-day Gemini 5 mission.
Astronauts L. Gordon Cooper and Charles Pete Conrad are piloting their Gemini 5 spacecraft into the 69th revolution around Earth, headed for the world's manned space-time record, 7.5 orbits away.
Go for the full amount of 8 days as was scheduled earlier.
Mission complete. Proof of our growing space-age experience in meeting with unexpected situations in flight. GT6, the first rendezvous and docking mission, was scheduled for October. Astronauts Wally Schirra and Tom Stafford were already in their spacecraft when the Agena target vehicle atop an Atlas booster blasted from the old Mercury Complex 14. After approximately 6 minutes of flight, telemetry signals were lost. The Agena never achieved orbit. GT6 was scrubbed. The big question now was the effect it would have on the program schedule. Disappointment was short-lived. President Johnson announced an exciting alternative. GT7, a 14-day flight, was already on the board for a December launch. Confidence in the launch team was a well-established fact. These elements shaped a real challenge. Launched GT-7 with astronauts Jim Lovell and Frank Borman, and within 14 days, launched the delayed GT-6 astronauts from the same pad to effect a close-in orbital rendezvous. GT-7, the first leg of the ambitious double Gemini mission, was launched on December 4th on its marathon 332-hour flight. While Lovell and Borman were still in their first orbit 185 miles above, the launch crew moved the Titan booster to the complex and worked around the clock to prepare GT-6 for its date in space. The fast turnaround was an unprecedented feat, and on December 15th, after a frustrating delay, Schirra and Stafford roared away for their rendezvous with GT-7. "185 miles above the Pacific Ocean, Gemini 6 took a giant step forward for the United States as it maneuvered to within 1 foot of its sister spacecraft. An historic space-age first in the race to land men on the moon in this decade. 1965 was a year of achievement and fulfillment at Cape Kennedy, but the challenge ahead remains undiminished because man's move into space offers infinite promise.